Hi there, and welcome to Transforming Security with Incident Response Automation. My name is Kimberly Chow, and I'm a specialist security architect here at AWS ASEAN. Today, we will be learning about security incident response, focusing on the fundamentals of responding to security incidents within your AWS Cloud environment. Firstly, we will speak specifically around how to prepare your organization for detecting and responding to security incidents. We will explore existing AWS native controls and capabilities, as well as look at remediation methods that leverage automation to improve response speed. So for the foundations of incident response, using AWS, you as an organization gains the control and confidence that you need to securely run your business with the most flexible and secure cloud computing environment today. Going back to the fundamental benefits of cloud security with AWS, you have the following. Firstly, inheriting the most comprehensive security and compliance controls. To aid your compliance efforts, AWS regularly achieves third-party validation for thousands of global compliance requirements that we continuously monitor to help you meet security and compliance standards for finance, retail, and healthcare. Secondly, building with the highest standards of privacy and data security. With AWS, you can build on the most secure global infrastructure, knowing you always own your data, including the ability to encrypt it, move it, and manage retention. All data flowing across the AWS global network that interconnects our data centers and regions is automatically encrypted at the physical layer before it leaves our facilities. Additional encryption layers exist as well. For example, all VPC cross-region peering traffic and customer or service-to-service TLS connections. Thirdly, having the largest ecosystem of security partners and solutions. We have carefully selected providers with deep expertise and proven success securing every stage of cloud adoption, from initial migration through to ongoing day-to-day management. However, what I would like to focus on today are two key benefits of AWS security. Firstly, scaling securely with superior visibility and control. When it comes to responding to security incidents, we have a saying within the security world that you cannot protect what you cannot see. AWS gives you that transparency to visualize which resources, assets, and data you have deployed within the cloud at any given point of time. What this in turn gives you is the ability to continuously monitor for real-time security information to ensure that the right resources have the right security controls applied at all times, as well as the ability to respond to security incidents that are occurring in real time. Secondly, automate and reduce risks with deeply integrated services. Automating security tasks on AWS enables you to be more secure by reducing human configuration errors and giving your team more time to focus on work that is critical to your business. From an incident response perspective, automating incident response helps you scale your capabilities, rapidly reduce the scope of compromised resources, and reduce repetitive work by security teams. Now, let's set the scene. Imagine this. It is 2 p.m. on a Friday. Everything is quiet. And because we are still in lockdown due to COVID-19, the security team is currently working from home and dispersed geographically across not only Singapore, but other countries as well across different time zones. In terms of your architecture, you have a single account, and you have segregated your development, test, and production accounts with different VPCs, not by accounts. You currently share multiple users within your account, including access to your root user. All users within your account has been given administrative access. The idea being that it would be easier to operate on AWS if everybody has the same access to everything. After all, you think you are only using AWS for a non-critical workload. You currently store data within S3, but this data is mainly what's required for your static website, as well as snapshots required for backup and disaster recovery. You also have some logs within this account, namely AWS Cloud Trail logs that you use to capture all API-level activity within your account, as well as Amazon Cloudwatch logs to capture operational and application metrics. Whilst this already sounds like the perfect storm, you have only one thing going for you. You currently use AWS Key Management Service to encrypt some objects. However, encryption is not uniformly applied at either the bucket or at an account level. Your key administrators and your key users have also not been properly defined, meaning that users within your account can both create and manage cryptographic keys, as well as perform cryptographic functions such as KMS encrypt and KMS decrypt, with no real segregation of duties in place at the key management level. So, are you surprised by this pretend architecture? Is this something that you think that you would not do within your own environment? Stepping back from this pretend scenario, as an AWS security architect, I often meet customers who have set up their AWS accounts with this exact same configuration and architecture. They set this up with the best intentions, in order for them to move fast and deploy quickly in order to meet their customer demands. Sometimes forgoing the additional step of reviewing AWS security best practices in favor of development. This leaves many organizations open to the possibilities of being breached. At AWS, we say that security is job zero for a reason. If you build in robust, resilient, and secure applications from the beginning, it will be easier and safer for you to continue to grow and scale in the cloud. Now, back to this scenario. It's Friday at 2 p.m., and an email comes in from AWS Security. Dear customer, Amazon Web Services has opened a case on your behalf. Your AWS account has been compromised. Please take immediate actions to secure your account. You, as a security operations personnel, checks that the email has come from a legitimate source and is not a phishing attempt. Now, what would you do? Before we start to deep dive into the AWS Security Incident Response Guidelines, let's talk about some key statistics. According to the Cost of a Data Breach Report 2020 by the Ponemon Institute, the global average cost of a data breach in 2020 is $3.86 million, with healthcare having the highest industry average cost at $7.13 million. Putting this into the context of COVID-19 and the current ramifications on security, 76% of all respondents said that remote work would increase the time to identify and contain a data breach. Furthermore, the remote work impact on the average cost of a data breach is estimated at $137,000. In terms of detection, the average time to identify and contain a breach has now grown from 200 to 280 days in 2020. One good thing, however, that the same report notes is that incident response and security automation shows the greatest potential for companies to reduce the financial impact of a data breach. In particular, the Ponemon Institute notes that in an organization which has deployed security automation versus an organization with no automation deployed, the potential cost of savings during a breach is $3.58 million. The report also notes that in terms of incident response, organizations which have tested their incident response plans can expect to save up to $2 million as compared to organizations that have done no testing. So as you can see, there are things that you can do within your organization in order to reduce or mitigate the impact of a data breach. Now, how would AWS do things? Let's start with what you can do to ensure a robust security incidents program. Please note that the following slides and best practices have been obtained from the AWS Security Incident Response Guide. The full guide can be located at the link at the bottom of the screen. It would be prudent for anybody in a security role to read the incident response guide, as well as to implement some of the controls listed within your organization. You begin by thinking about building the foundations of a successful incident response program. In order for incident response to succeed, security staff should be integrated with the application development process in order to deeply understand the objectives of the application, establish security baselines, and learn how to react to potential security issues. Following on from that, bringing both security and development teams together, you need to educate them. Ensure that you educate your security operations and incident response staff about cloud technologies and how your organization intends to use them. Prepare your incident response team to detect and respond to incidents in the cloud, enabling detective capabilities and ensuring appropriate access to the necessary tools and cloud services. Additionally, prepare the necessary runbooks, both manual and automated, to ensure reliable and consistent responses. Work with other teams to establish expected baseline operations and use that knowledge to identify deviations from those normal operations. Understand the differences between a playbook and a runbook. Whilst playbooks look at the non-technical strategic initiatives around security response and normally involve strategic planning for the future, runbooks represent a tactical review of a situation. Description of situations that may occur, for example, a data breach of sensitive PII data, steps to correct or enact a desired outcome. It would also have a prescriptive contact list of people responsible for the application, as well as a security response. Both of these are equally important. Make sure that you simulate and test both expected and unexpected security events within your cloud environment to understand the effectiveness of your preparation. This could include both a tabletop as well as a technical exercise. Whilst tabletop exercises include role play, following an incident from start to finish in order to test the key decision points listed in a playbook or runbook. A technical exercise would include executing a technical action in an environment, for example, red teaming exercises or taking part in a cyber range. Technical exercises typically observe the response of the organization and assesses the success of the organization in handling an incident in terms of time to detect, time to respond, effectiveness of response, and lessons learned. Make sure that you continuously iterate on the outcome of the simulation to improve the scale of your response posture, reduce time to value, and further reduce risk. You also need to think about establishing specific design goals that are relevant to responding to security incidents in a cloud environment. Again, these design goals can be found in the AWS Security Incident Response Guide. Establish response objectives. Work with your stakeholders, legal counsel, and organizational leadership to determine the goal of responding to an incident. Some common goals include containing and mitigating the issue, recovering the affected resources, preserving data for forensics, and attribution. Respond using the cloud. Make sure that you implement your response patterns where the event and data occurs. Know what you have and what you need. Preserve logs, snapshots, and other evidence by copying them to a centralized security cloud account. Use tags, metadata, and mechanisms that enforce retention policies. Use redeployment mechanisms. If a security anomaly can be attributed to a misconfiguration, the remediation might be as simple as removing the variance by redeploying the resources with the proper configuration. When possible, make your response mechanisms safe to execute more than once and on unknown states. Automate where possible. As you see issues or incidents repeat, build mechanisms that programmatically triage and respond to common situations. On the other hand, you should use human responses for unique, new, and sensitive incidents until you're able to normalize these patterns. Choose scalable solutions. Strive to match the scalability of your organization's approach to cloud computing and reduce the time between detection and response. Learn and improve your processes. When you identify gaps in your process, tools, or people, plan to fix them. Simulations are safe methods to find gaps and improve processes. Next, you also need to understand the key indicators of cloud security events. There are many security events that you might not classify as an incident. However, it is still prudent for you to investigate. You can use some of these examples to detect security-related events in your AWS Cloud environment. As you can see on the screen, this is a common architecture for security event monitoring using a whole host of different AWS services. AWS services, in this case, act as your data sources, for example, VPC flow logs, AWS CloudTrail logs that feed into services such as Amazon Cloudwatch for incident detection and event monitoring. This is just one design pattern amongst many that you can use to build a security monitoring tool on AWS. Some potential indicators that could warn you of a security event in this architecture could be your logs and monitors. You need to review AWS logs such as Amazon CloudTrail, Amazon S3 Access logs, and VPC flow logs, and security monitoring services such as Amazon GuardDuty, Amazon Detective, and AWS Security Hub, as well as Amazon Macie. In addition, use monitors like Amazon Route 53 health checks and Amazon CloudWatch alarms. We will learn more about some of these security monitoring services in the security automation section of this workshop. Specific CloudWatch alarms are also another indicator that you should be looking out for. You could have configured specific CloudWatch alarms to look at specific metrics such as a sudden spike in billing activity. This could indicate compromise, as a spike could indicate that a large amount of resources are being spun up and consumed. This is definitely something that you should be looking out for. Threat intelligence and partner tools are also another option. If you subscribe to a third-party threat intelligence feed, you can correlate your information and other AWS security tools such as GuardDuty or Security Hub to further identify potential indicators of security events. One-time contact. As an example here, somebody may have been watching the AWS Personal Health Dashboard or received an alert from the Personal Health Dashboard, which provides alerts and remediation guidance when AWS is experiencing events that may impact our customers. It is important for your organization to understand when to notice something unusual and to contact the relevant people. If your organization works with the general public, you may also need a public-facing security contact mechanism. AWS support. As in the scenario presented in the beginning of this workshop, AWS support may contact you if we identify abusive or malicious activity. Like I mentioned before, this is not an exhaustive list of key security indicators, and customers should build their own security monitoring tools and use cases based on their understanding of the application and security baselines, and to ensure that these have been sufficiently documented in order to weed out any possible false positives. Moving on to some practical aspects of incident response. If you suspect that your account is compromised, what should your first steps be in order to secure your AWS account? Number 1, don't panic. Contact your AWS account manager and AWS solutions architect immediately. If you do not have either, raise a Severity 2 support ticket. We believe that every single customer security event should be investigated and treated seriously, so never be afraid to over-escalate. Ensure that relevant people within your organization and/or regulators, for example, the Personal Data Protection Commission, have been made aware of this potential security incident. Turn on multi-factor authentication on all of your users, especially on the root user. Rotate all credentials, including AWS access keys and passwords. Turn on AWS security services for security event logging and monitoring, such as Amazon Guard Duty and AWS Cloud Trail. Configure Cloudwatch alarms to monitor specific API activities, such as console login. If an account is usually accessed programmatically by a user, anybody logging in should be treated as suspicious. Stop logging. This is a huge red flag, indicating that an attacker wants to ensure no record is made of the malicious activities. The creation of resources, as well as the escalation of privileges directly after a potential security event is identified, should also be treated as suspicious. In this case, we have creating users, adding users to group, attaching policies, attaching role policies, creating access keys, creating groups, or creating roles. The creation of all of these resources should definitely be treated as suspicious. Anything to do with your network. Here are just some of them. Creating a new network ACL, creating network ACL entries, creating routes, creating security groups, or authorizing egress as well as ingress on your security groups. Prepare to triage an incident. Isolate compromised instances by reducing or terminating ingress and egress traffic. You will then need to deep dive into your logs with or without the help of AWS support or AWS partner support with services such as Amazon Athena. Using Amazon Athena to query CloudTrail logs and other forensic activities are, however, outside the scope of this particular workshop. Now that we have thoroughly gone through the processes to set up a robust security incident response plan, as well as actions we should do immediately to secure our AWS account post-compromise, let's move on to talking about security automation and remediating security events automatically using AWS services such as Amazon Guard Duty, Cloudwatch events, AWS Security Hub, and AWS Lambda. First, let's quickly understand some of the AWS services that we will be exploring in our solution today. First up, Amazon Guard Duty. Amazon Guard Duty is our managed threat detection service that continuously monitors for malicious activity and unauthorized behavior to protect your accounts, workloads, and data stored in Amazon S3. Guard Duty analyzes continuous streams of metadata generated from your account and network activity found in AWS Cloud Trail events, Amazon VPC flow logs, and DNS logs. It also uses integrated threat intelligence, such as known malicious IP addresses, anomaly detection, and machine learning to identify threats more accurately. Guard Duty looks at over 65 different findings across 4 threat detection classes, the latest being Guard Duty Protection for Amazon S3. As you can see, Guard Duty runs the gamut from external attacks to unusual behaviors within your workloads, accounts, and S3 buckets. Next, we have AWS Security Hub. AWS Security Hub provides you with a comprehensive view of your security state within AWS and your compliance with security standards and best practices. Security Hub centralizes and prioritizes security findings from across and between your AWS accounts, services, and supported third-party partners to help you analyze your security trends and identify the highest priority security issues. AWS Security Hub also comes pre-built with 3 compliance programs in order for you to check your security posture against AWS security best practices, PCI DSS, and CIS benchmarks for AWS. Amazon Cloudwatch, now also known as Amazon Event Bridge, is a monitoring service for AWS Cloud resources and the applications you run on AWS. You can use Amazon Cloudwatch to collect and track metrics, collect and monitor log files, as well as set alarms. Amazon Cloudwatch can monitor AWS resources such as Amazon EC2 instances, Amazon DynamoDB tables, and Amazon RDS-DB instances, as well as any custom metrics generated by your applications and services, and any log files your applications generate. You can use Amazon Cloudwatch to gain system-wide visibility into resource utilization, application performance, and operational health. You can use these insights to react and keep your application running smoothly. To get started with the monitoring, you can use automatic dashboards with built-in AWS best practices, explore account and resource-based view of metrics and alarms, and easily drill down to understand the root cause of performance issues. All three of these services are part of what we call our no-brainer security services. You should also have all of these three implemented to protect your accounts, your workloads, and data. In today's demo, we will see how we can automate the remediation of security events that are identified by GuardDuty and Security Hub using AWS Event Bridge, also known as Amazon Cloudwatch, as well as Amazon Lambda. We'll be using a few simple but effective examples to show you how this can be done. We will be looking at some of these common security events. I'm going to show you two demos. The first demo includes CloudTrail logging, and the second demo will include when somebody changes a password policy. What we're going to be seeing in the backend is that automation is going to be set up to revert these changes to their original state. So you'll see how this happens in real time. I'm actually going to be starting first with CloudTrail. What you'll see here is I set up all of these trails to begin with. So if I go into trails, you will see that I have all of these trails, but I'm going to be focusing on this one, CloudTrail Test 12. So what I'm going to be doing here is that I'm going to be turning logging off. Okay, so this is what an attacker will do if he gets into your account. The first thing they're going to want to do is they're going to turn off logging so you can't see their activities or what they're going to be doing within your account. So I'm going to click Stop Logging. Okay. And then I'm going to go into Cloudwatch events. So you can actually set up a multitude of different Cloudwatch events. If I go into the rules, you will see that I have all of this already set up in my account. And the idea is that this particular Cloudwatch event will trigger when something changes. For example, this one here, CloudTrail Stop Logging. You will see that it is importing findings from Security Hub, specifically when somebody has disabled CloudTrail logging. How this works is if you go into Lambda, basically, my Lambda function will re-enable CloudTrail logging, but it will also send me an email automatically when something happens, and it will show me that somebody has turned off my CloudTrail logs. So if I go back now into my email, you'll see that I've already gotten an email that shows me that somebody has turned off CloudTrail logging, and CloudTrail logging has already restarted automatically. If I go back into my CloudTrail logs, I'm just going to check whether or not logging has automatically been turned back on. Okay, back into my trails. Okay, as you can see, it's automatically being reverted. Now moving on to another example, which is often overlooked, changes in password policies. Password policies still have a part to play when it comes to securing your console logins, especially if you do not currently federate your identity using our Active Directory on AWS services. As you can see, I have a very strong password policy set up, but I'm going to go ahead now and change my password policy. Okay. I'm going to save changes, and you can see that my password policy has been updated, and I've got a very weak password policy now. I'm going to show you something different now by going into Security Hub. If I click into Security Hub and then down into Security Standards, you'll see that Security Hub has 3 separate standards, but we will focus on the CIS Benchmarks version 1.2. So AWS and CIS has codified all of these compliance checks. But of course, what I'm most interested in would be CIS 1.5 to 1.11, which are the password type findings. So if I scroll down into 1.5 to 1.11, you will see that all of these password checks have something called one-in warning. So it's basically showing me that there is a non-compliance with this particular password policy. I'm going to click into this now. Okay. And as you can see, I've set up some custom actions, and I've set up one to remediate 1.5 to 1.11. If I go into my Cloudwatch, let's actually see what that remediation does. Okay, so I've set up some rules here. So 1.5 to 1.11 basically remediates CIS checks 1.5 to 1.11 by establishing a strong compliant password policy. Okay, now back into Security Hub. I'm now going to remediate this using those custom actions you saw earlier. Okay, I'm going to click on 1.5. Back to my finding, and I'll click Remediate. You will see that I've successfully sent findings to Amazon Cloudwatch events. I'll now go back into IAM to look at whether or not these changes have been made. Okay, and as you can see, it's already been reverted. So the power of automation really is that it can help your level 1 SOC analyst scale, and you can remediate findings even before they have been detected. There are many more types of security automation that you can do, from changing network ACL rules to stop malicious traffic, to isolating your EC2 instances for forensic analysis. Step-by-step examples on how to do this are documented in our AWS security blogs, as well as the AWS Security Incident Response Guide. Thank you for attending the talk today on security incident response and automation. If you would like to know how we can help, please feel free to reach out to us on any of the following that you see on screen. You may also reach out directly to me if you have specific security questions. Please remember to fill in the session survey on your way out. Until then, stay safe and keep building.